Welcome everyone to the Flux Dev Meeting, the public dev meeting for May 8th, 2024. We're just setting up our agenda right now. We're waiting for a few more people to get started, but I wanted to start the recording so we can capture any discussion. Um, is there anyone who'd like to talk about anything first? We have a few items on the agenda already. The upcoming release we're going to talk about today. The Helm controller update is also part of the upcoming release. And an open invitation to anyone in the room who'd like to add something to the agenda. If you don't have access to edit the meeting notes, you can send me a DM or you can just speak the item and we'll add it to the agenda for us. Welcome everyone if this is your first time at the Flux Dev meeting.
Thank you. Good to be here.
Thanks for joining us. Sorry about this slower than usual start this morning.
Let's go through the preparation list.
Sure. Where should I start?
A lot of sub projects are changing. We can start with maybe image automation. That's kind of independent, and then source controller and Helm controller are related, right? So image automation went through a refactor in this release, and it's being promoted. The API is being promoted to V1 beta 2. The whole reconciliation loop has been refactored, and the way it interacts with the Git repository has also been changed. It should be easier to develop and add more tests where we need. And it also has some changes to how the updates are, what's that called? I forgot the term. But do you remember the selector or something, right? The kingdom that you add in the YAML files for updating?
As far as I'm aware, I think there was a change for digest in the selectors. I'm not aware of any other change in the selectors, though.
What's the name? The image policy selector is a new feature. But what's the thing you add in the YAML file to update them? What's that called?
I'm not sure if you're talking about something on
Marker. It's just a marker.
Oh, the
You mark
markers,
it with the image policy name, right? So that has been the result of the marker has been changed now. It used to be called just the result. Now we have a result v2. It's an internal change. It's a backwards compatible change. The effect of this would be users would be able uh, to render what got updated. Previously, we just used to add what images got updated. We didn't show what was it before, what is the new value. But now users can add what got updated from version X to Y. You can represent that in your commits or even Slack messages or any message alerts. And another new feature is image policies selected by image automation objects. Used to be all of the image policies in the namespace. Now, now there is a image policy selector, so you can select which image policies should be considered for a particular image update automation. Um, there have been some other performance improvements where we do not unnecessarily clone the repositories all the time now. We check if there is a change in the remote Git repository and if there is a change in the policies. If there is a change, we clone the repository and check if there is any update. If there is no change, we do not clone the objects. So it will help improve or help avoid unnecessary network traffic. I think these are the major changes. And we can talk about source controller. So with this GA of Helm, it is a Helm GA release. So Helm repository, Helm chart, and Helm release objects are being promoted to V1 API. And I don't think there is much change in the source side. Helm repository and charts remain the same, but there are changes in Helm release. I think one of the major changes is previously Helm release used to create Helm chart. It does that still, but now you can create Helm chart yourself, and a Helm release can refer to that Helm chart. So you can have one Helm chart referred by multiple Helm releases. Previously, we didn't support that. And Helm releases now also support OCI Helm charts, or OCI repository, not Helm charts, sorry. So Helm release can get the chart from OCI repository, which can contain an OCI Helm chart. I think this is a major new feature. Is there anything else, Kingdom? Do you remember?
Off the
Any
top
new feature?
of my head, no. It's still very early here, so it's possible I'm not thinking of something. I'm also dealing with my screen shares doing an awkward thing, or I've actually lost control of my screen. I'm going to stop sharing here.
Okay, that's okay. And I think in the CLI, Flux CLI will also have now commands for interacting with Helm charts. Previously, we just used to have subcommands for Helm repository and Helm release. Helm chart used to be something in the background. Now, CLI will allow users to create Helm charts, which can be reused across multiple Helm releases.
That is excellent. That is a highly requested feature.
What else? Oh, in source controller, we are adding notation support. That's a big feature. So we used to support cosign before for source verification for OCI repository and Helm charts. Now we also support notation. What else? I think these are the big features, and there are many other minor bug fixes or improvements. And we'll be supporting Kubernetes 130. All the dependencies have been updated to 130. Oh, there is CD events support. So notification controller has a new receiver for CD events. So you can connect their CD events message broker to Flux, and it can trigger Flux objects or Flux controllers.
Cool. What else are we missing?
Mm.
I'm just scanning through the list of PRs merged here.
Yesterday, somebody created a pull request for a Flux push artifact command to make the artifact reproducible, and that got merged.
Oh,
Uh,
great. I see.
it's a very recent change from just yesterday. So you can uh, have the same generated digest for the same content now. Using a new flag called -hyphen reproducible in Flux push artifact. And I think there will be a lot of improvements in Terraform provider for any people who use Terraform provider. I have not seen what are the improvements, but I've seen a lot is happening. Now, along with these, all the API updates, we are deprecating the previous API versions. Hem release V1 beta 2, V2 beta 2 have been deprecated, but not removed. They'll continue to work. Hem repository V1 beta 2 deprecated, hem chat V1 beta 2 deprecated. They'll continue to work, but after 6 months, they may not work. So we recommend people to upgrade to the latest API version. And same for image automation, image update automation. V1 beta 2 is a new version. V1 beta 1 is deprecated. And for image automation, the message templates will continue to work, but we have a new message template that we are recommending to migrate. I think that's it. I don't see anything else. Oh,
Hey,
Stefan is here. Hi.
I can say a few words about Terraform provider. So we have deleted the old providers, which were deprecated last year. That's a big change. So everyone who hasn't yet migrated, they can no longer upgrade to Flux 2.3. You need to migrate to the Bootstrap provider. And the Bootstrap provider has been majorly improved to detect drift in cluster. So the problem with how the Bootstrap provider was implemented was that it only looked at the state in the Git repo. So let's say you bootstrap a cluster, then you delete the cluster and recreate it. Rerunning Terraform apply would say everything is up to date because Terraform will only look at the files in the Git repo. The big change I did for this release is that now Terraform looks also at the cluster state, and it basically does a health check of all the Flux installation, similar to Flux check. And if, let's say, Flux is not there or the reconciliation fails for some reason, let's say you deleted the secret or whatever, um, the Terraform plan will report the drift. And then when you apply it, it will try to restore Flux to a good state. If Flux is not installed, it will reinstall it. If things are missing, it will restore them, and so on. So that's a big change. Another one which was highly requested in the past. As you know, the Flux CLI can be used to bootstrap Flux on air-gapped environments. And how we managed to do that is the fact that the Flux CLI binary embeds the Flux manifest inside. So if you run the Flux bootstrap command, the CLI will not go to GitHub to download the manifests. It will use them from the binary itself. So we added this feature also to Terraform provider. The next version of the provider inside the binary will contain the manifests, and you have to tell the provider to use the manifest from which are embedded. So this enables basically the same workflow as with the CLI when you are using air-gapped environments. We have other things. We have completely rewrote all the examples and the docs. And Steve Wade, which is now a Terraform provider maintainer, he also tested the new provider with OpenTofu. So the provider is not only now about Terraform, it's fully compatible with OpenTofu, and we moved all the documentation and all the examples in the repo. We no longer publish them to the HashiCorp website. Basically, on the HashiCorp website is just an introduction to the provider. Then there are links back to the docs, which are now hosted in our Git repo. So yeah, that's about it around the provider. Any questions?
How does also publish to our website? Terraform provider docs.
What?
Are the Terraform provider docs also published to Flux website?
So
Or
on
is
the
it just in the repository?
no, on the Flux website, we are going to have links back to the repo where all the examples and the documentation is. But yeah, we should probably try to have a page on the website with all the provider options. Right now, that page, there are two pages for the provider and the resource itself, and they are generated from Terraform with the Terraform docs plugin. But yeah, we should definitely have a page on the FluxCD website and no longer point people to the HashiCorp website at all. The problem is the way the markdown is generated is not compatible with our website because the website needs some headers, some comments. I don't know, we need to look into how we can modify the website script to pull the markdown and maybe inject those headers, something like that.
So we have the external sources script, which does inject headers. So we can use that, I think.
Yeah, that's the place where we could do it.
I have to go in
Is
just
it
a minute or two, but if you need me to do anything like that, just send me a DM. I'm gonna have to delegate the host to someone here because I have to help someone move.
I was about
Okay.
to ask, is it the same thing that the tooling you use for the KubeCon website for mirroring the content?
Yes.
Okay.
Yeah. We can go as deeply into that as you want. I'm not sure it's necessary. We added a trigger so that a change in one of the relevant files in the community repo will directly trigger a build on the website repo. So we could do a similar thing with the Terraform provider. But I don't know if it's necessary because it's every time the build is run, it will get updated anyway. I have the link now. So
Yeah, another thing we need to discuss, Sunny, is around maybe delaying the release.
What about it?
So delaying the release, we should do the release tomorrow because we said we are not going to do major Flux releases on a Friday. But I'm looking at Helm controller and you have this.
Oh,
Yeah.
my recent pull request. No, that's not necessary. I discussed with Sule. You're like the feature about post uh, rendering digest observation. It works. This is just an improvement. It's just moving around the code, but it'll work as it works now. It can be added later.
I don't know, I'm reading your description and it feels like the atomic reconciliation will get stuck with the current implementation.
No,
Or
no, it will not get stuck. So my description is about when it was in summarize, any sub-reconciler that calls summarize and ready becomes true, it will update the observation,
Mhm.
because of which we do not get stuck. But with this change, I'm moving the update code out of summarize. In this case, when there is a summarize call, it will not automatically update the observation, because of which, so observation gets updated at the end of reconciliation now. So if a reconciliation, if a complete reconciliation has multiple upgrade sub-reconciliations, they will not have the observation updated. So in
Mhm.
this, I'm adding a conditional for checking the, it's stuttering. I added a condition for checking the digest. Only when there's a new configuration, check the digest. And we are reconciling on a configuration that has been processed already. We don't need to check the render digest. We've been
Okay.
testing it. We'll discuss more with Sunny, but the output should be the same. It's just moving around the code. You can add
Yeah,
it in the patch release.
yeah, another issue that Sule found is around. So I added the app version because so many people wanted app version in the Helm controller events. But now, because I added the app version to the status
Snapshot.
history, now it breaks the upgrade. Basically, when you go to from V2 beta 1 or V2 beta 2 to V2, the
Mhm.
controller will say that it doesn't know about this release because the history doesn't match.
Mhm.
So
It'll
we,
trigger an upgrade.
yeah, it will trigger an upgrade for everything. So that's really, really bad. And Sules said he will um, open a pull request to fix it today. Yeah, I'm depending on that. We will decide if we move forward or we delay the release for Monday.
This can be a good reason to delay. Yeah.
What?
No, this can be a good reason to delay. We can fix this properly.
Yeah, I also put the release pull request on hold until we have this one. And after when Sule will open the pull request, can you please also test the upgrade with it?
And that's it.
Yeah. Hey, I'm seeing a bunch of Romanian people here. What's up? Hello.
Yeah, hi Stefan. Hello.
Hey.
Good. I think we've met at the KCD event. I'm not sure if you remember me. Maybe let me turn on my camera.
Hey,
Is right?
yeah, yeah.
Yeah. Hi, hi. Yeah, yeah.
Hi, man. How are you
Yeah, it
doing?
was a nice event. It was a nice event. I've really enjoyed it and lots of good presentations there.
Yeah, yeah, it was awesome. Hopefully the next one it will be even bigger.
Yeah, but for the first time in Romania, I think it was plentiful.
Yeah,
Like good
yeah,
presentations, a good after party.
yeah. It was my first KCD. I haven't attended others in other countries, and I was really impressed with it. Felt like KubeCon many years ago. Mm.
What's KCD? Kubernetes Continuous Delivery.
No, Kubernetes Days. It's
Oh, okay.
I think also
Community days.
India. Kubernetes Community Days.
I've heard about it.
And it's once per year in many countries, and it's growing bigger. It's basically let's say a variant of KubeCon at country
Smaller
level.
scale.
Yeah, smaller scale. Yeah, but it's nice. All the talks are in English as well, so it is not only about that particular country. Speakers from all around the world come to these events, and I feel like I don't know. Given the fact that it's one day, it's way smaller. You get to socialize more. Or I don't know. It feels less. It's less of a pressure on also on speakers and everything, right? You don't have 5K people in a room uh, and huge boosts and all of that, right? So yeah, uh, it's a great place to meet other maintainers and users. I've met a bunch of Flux users in Romania that I didn't know they were there, so that was nice for me. Any other things on the agenda?
Yeah, just release preparation.
Yeah, we're going to need a bunch of things, bunch of work after we release Helm controller. So we need to migrate the CLI to the new version, and I created some issues around it. We also need to remove the warning and make all the commands GA around
You
Helm.
did
And
that. You did that already?
no, I did it for
Well, for source queue.
one, right? So we need to also do it for all the Helm release commands. And now because we have chart ref, right, as an option, we need to enable that so people can generate Helm releases with the CLI using OCI repo or Helm chart directly. Sule has a pull request in draft for this, and I've talked to him, and today and tomorrow, there are bank holidays in France. So yeah, I'll probably take over that pull request, and you could review it. But yeah, we need to release Helm controller before anything. I also run the benchmarks for with a build from the main branch of Helm controller, and Yeah, things look really good. I've merged the benchmark and I have to update it after we release Helm controller. There is a huge change, a huge improvement when you have lots of CRDs. So what happened with all Helm controller releases until now is that the controller uses more memory and more CPU, the more CRDs you have, not CRs, CRDs. So for example, if you install Crossplane or whatever, this crazy project which comes with thousands of CRDs or whatever, right? AWS has something like that. Azure, all clouds have it. Also Crossplane, which integrates with all of them. So the more CRDs you add, because the Helm SDK does all sorts of discovery calls to the API, it loads into memory several times for each Helm release all the open API spec of all the CRDs available in the API. So in Flux 2.2, if you run the benchmarks with 500 CRDs registered on the cluster, everything will run out of memory. Helm controller needs huge amounts of memory to deal with that. With Flux 2.3, it works with 1 GB of memory. I've tested even with 1,000 CRDs. So that's a huge improvement.
Oh, where was the change? Was it upstream Helm change or change?
So there are many changes which helped here. For example, we made a change in our own manifests where for each controller now we help the garbage collector. We tell go garbage collector what's the maximum memory it has. And we also tell the go runtime the amount of threads it has available. So the problem is in Kubernetes, and that applies to any Go application. So if you deploy a Go app in Kubernetes, and the node where the pod is running has, let's say, 32 CPUs, even if you set a limit to 1 CPU, the Go runtime will see the number of CPUs available on the host, on the node. So by default, it says, okay, I have 32 threads that I can deal with. But then with cgroup, you limit it to 1 CPU. And what this means, you'll be running into huge thread contention because the Go runtime tries to move Go routines to dedicate threads. Then the host OS will say, no, 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 you have only 1 CPU and you'll have huge CPU throttling. While CPU throttling happens, the side effect of it is that garbage collection stops. So when Helm controller does an upgrade, it requests from the API all the CRDs. What happens into memory is the API will respond with the Open API spec. The Open API spec will be converted from JSON to Go objects into memory. So you'll have twice the same information into memory for all the CRDs. Then it does the validation, and then that routine ends. So if you have, let's say, 10 Helm upgrades in parallel, you'll have all the Open API spec twice, 10 times, so 20 times into memory. And the garbage collector has to come and clean it up while the Helm controller moves to the next upgrade. But it can't do it if the CPU is throttled. So it will never clean those up and you'll get to out of memory. So setting those environment variables, helping out the Go runtime to actually know what are the constraints of the container helped with cleaning up memory faster and being more performant on that side. that's one thing that helped. Another thing that helped is that upstream Kubernetes has made GA the aggregation discovery API. So what this means is that with aggregation, instead of, so you have, let's say, 1,000 CRDs, every CRD has 1 to 3 versions. What that means is that on every upgrade, Helm controller will perform 5,000 HTTP calls to the API to get each open API spec for each version of each CRD. And all these calls, what it means is that you make all these, is basically you're DDoSing the Kubernetes API. But let's go beyond that. There's not an issue for auto memory. What the problem is that if you have all these calls, then you allocate memory on all these go routines. The aggregation API, the major change that happened upstream is that now when Helm calls the discovery API, instead of having all these thousands of calls, you make only one call, which gives you a dump of all the API specs, all the versions, all the known kinds, and you return that result in a single go routine. You process it, then the garbage collector comes and cleans the memory. So having these two improvements helped keep the Helm controller around 600, 800 megabyte of memory for 1,000 CRDs. And I've tested with, so the benchmark now is doing 50, 500, 1K, whatever. And the differences are not that big now. Even if you add more CRDs, our memory does not grow along with them because now the garbage collector is very fast. We only make one call every time, no matter how many CRDs there are. So you don't have that problem with the more CRDs, the more HTTP calls, the more memory you need to clean up and all that stuff that happens. So both these things together, an optimization from our side and the aggregation API on the Kubernetes side, made this issue not being that impactful to Flux. I'm really happy about it because the only way you could actually solve this is for Helm to not make any calls to the discovery API. Flux itself, for example, if you use Flux customization, we don't make that calls. We don't need to know which APIs are registered because we use server-side apply. So we don't need to do any validation on the client side. We send the patches to Kubernetes API, and the Kubernetes API uses the open API, which is already cached in the API server itself. So we don't need to move like the whole storage, all these definitions from the API to the client in our controller to do validation. So for some time, I thought, oh, if let's say Helm version 4 will go with server-side apply, all these things will be fixed magically. But then rereading all the Helm code, I realized that in fact, it will not, they can't actually switch to server-side apply and no longer do discovery API calls. Even if they switch to server-side apply in Helm version 4, they still need all the custom resources definitions on the client side because they have this capability API in Helm. So in Helm, you have these capabilities and you can say, if the server has this kind at this version, I want to template this stuff, right? So Helm itself needs to know all the APIs, all the versions in order to, have this capability.
Client-side logic.
Yeah, client-side logic based on that. So even if they switch to server-side apply, you can't get rid of the discovery API, but you will not have to make so many calls to the discovery API. You will only need to make a single call to the discovery API just before you run the Helm templating. And that's it. Now they have to call it every time because they don't know. You can put CRDs everywhere in a webhook, in the CRDs directory, in the template directory, whatever. And because of the client side apply, you every time you apply something, you need to invalidate the client cache, get all the APIs again because you don't know what changed, right? And do this stuff, all these calls at every stage of the Helm reconciler, which is like really, really bad. But anyway, the aggregation API solved so many things, and now with optimization for the Go runtime, we don't have to, say to people, yes, you need to give Flux gigabytes of memory just because Helm doesn't do server-side apply. So we are not in that position anymore, and I'm very happy with that improvement.
So
yeah.
this aggregation API is part of new Kubernetes version, or did we or Helm adopted it?
No.
You have to be in the latest cluster.
No, so the beauty of it is that it's implemented in client Go. So client Go queries the cluster, sees, oh, aggregation API is available in this cluster for this version. And when you call
It
the
does one call
discovery
instead of
client,
multiple calls.
it will do, instead of doing thousands of calls, it will do one. On all the clusters, it will do thousands of calls. So of course, it's like Flux users on Flux 2.3 with Kubernetes 129 and 130 will see this improvement. If you use a very old Kubernetes version, well, the garbage collector will move faster, so that will mean something. But you will still do all these thousands of API calls, right? And because Helm imports client Go. When we update client Go, we basically update what the Helm SDK is using, right? We don't use the binary. Helm controller uses all the SDK. So by just upgrading Helm, it's still on an older client Go version, but we moved to 130. So now we have the aggregation API GA also for the Helm calls, right? So Helm didn't have to change anything. Basically, you just use a new client Go. Helm uses the client Go discovery API from there, and that's how it goes.
Matthias is here. Hi. Matthias?
Hi. Sorry. Actually, the meeting is almost finishing. I just realized that there was gonna be one today now. Yeah, I just maybe wanted to give an update on the issue I'm working on that Stefan assigned to me, which is for adding support for custom CA for the bucket API for the generic provider. And yesterday I was able to test it end to end in my laptop with a kind cluster. So I spun up a MinIO pod and a source controller pod, and I was able to verify that if I, for example, didn't pass the cert secret with the CA, I would get like a TLS error. And then after specifying the cert secret in the bucket object, the TLS error was gone, and I was able to like get the artifact and verify the contents. So it's working well. And now I'm just finishing the PR, like I'm adding a test. The MinIO client is using the Docker test library, right, for spinning the temporary container. I'm trying now to make this work. Like I generated a CA in memory, and then self-signed CA in memory, and then a client using this CA, like a server certificate in keys in the CA, and I'm writing it to disk in the temp directory, and then mounting this on the MinIO container, but I'm getting a problem here with the health check like that runs before the test. It's trying to like it's giving me a problem here. Like it like times out. And then I try to
Container
hack
health.
this like instead of using the health check from the Minayo client, I tried to just like open a TCP connection and see if it would work. And looks like I'm able to like pass the like yes, I can create like I cannot dial a TCP connection, but then when I like when this test code for the Minayo client reaches the part of creating a bucket, now I'm getting this error. Client sent an HTTP request to an HTTPS server. So yeah, I'm just trying to understand what I can do here to make this test work. But it would be really great if I could make it work because it sounds like a good like integration test for the Minayo client. Yep,
You are
that's it.
referring to the min.io binary, right? The
Oh, sorry. I just realized I'm not listening.
Cannot hear us.
Um, I can hear you now. Sorry.
so you are referring to the MC binary, right? That we use in the end-to-end script.
No, no, there's in source controller there's package min.io underscore test. That file has some tests for the min.io client, and it like uses this um Docker test library that spins up a container. Do you see that?
Mhm.
I remember that. The health check you're mentioning, is it the Docker container health check or something else?
Yeah, like I was thinking the same thing, but it's like in like if you look at this file like a bit further below after like we create so there's this pool dot run with options and then there's like the container configuration from NIO and then a little bit further down, there's this pool dot retry, and then you pass a callback, and then in the callback, there's test min.io client dot health check. So it looks like an API of the min.io client library.
Yeah, of course. And
I
it
see.
needs the TA to make that call.
Sorry?
It needs the certificate authority.
Yeah, yeah. So, but the thing is, this client, it receives like I like so the client b before my change has like receives the bucket object, the secret object, and then I added a third parameter which is a TLS config.
Mhm.
So this is the TLS config that I was able to exercise end to end in my cluster locally. And the same code path is being exercised in the test as well, where like I pass this TLS config to the client constructor. So this health check should be using this TLS config, and it's not. And the TLS config is pretty much just a CA pool with this single self-signed CA certificate.
Mhm.
So yeah, it like
One thing,
sorry, go ahead.
did you add HTTPS prefix in the address? Because there you say it happens when you're connecting to
Yeah, so like
HTTPS.
it looks like this library, the constructor of the min.io client,
Mhm.
it doesn't accept the HTTP or HTTPS prefix on the URL. It's just the host and the host and the port, host colon port. It figures out the prefix internally. Um,
Mhm. Oh yeah, there is no HTTP. There is no protocol prefix to
yeah,
bucket,
yeah,
like a Docker container.
yeah, exactly.
You
So basically, like, mm, Yeah, it's because maybe this, yeah, maybe the way I'm doing it, it's weird because the MinIO library, it has this options object. Then what I'm doing is I'm passing a transport, like an HTTP round tripper, right?
Mm.
And I'm creating this transport. Like I went through the code of the library and they have this internal, actually it's public, like they have this public, this exported function that creates a default transport. And I looking at the code, it like it only takes one parameter, which is a Boolean saying secure, like true or false. And if it's true, it specifies the TLS client config field of this HTTP transport object. So basically what I did, since we have our own TLS config in this part of the code, right? Because that handy function for like parsing everything from a Kubernetes TLS secret object. Like I already have this TLS config object in my hands. I just have to replace it in this transport object. So that's why I'm passing false to this minio.default transport library. So it just creates for me the default transport. And then right after that, I assign the TLS client config field with the
So
one.
wait,
Sorry,
wait.
go ahead.
So I think this is the problem. So in the
Yeah,
chat,
yeah. Like
okay.
I sent you the draft PR. Like if you want to take a look at that. Are you looking?
So if you look
Uh,
in the
Sorry guys to interrupt. I'm gonna be going. Thank you for the tips
thanks,
and
Matt.
tricks, Stefan. Thank you. I see you. Bye guys. Sorry to interrupt. Bye.
So Matthew, I pasted the link in the chat. So the problem is, I think,
Mm-hmm.
the problem is that in all the tests, we set insecure true,
Mm-hmm.
which tells the client to use HTTP instead of HTTPS everywhere.
Mm-hmm. But in this case, like this line you sent me, you're setting insecure to true in the bucket object specification, right? In my test, like in this MinIO test, there's not even like, oh, actually, no, yeah, like yeah, this code here is not using the bucket API from Flux. Like it's just kind of an isolated test for the MinIO client. Let me push my current version here. Um,
But the new client accepts a source v1 bucket object, right? So if you configure it, it will be
in the test, mm,
the new client constructor accepts a bucket object.
oh, right. Oh my God. Yeah, you're right. Sorry.
Yeah, so so the problem is in new client, the new client receives a
Yeah.
bucket
Yeah,
definition.
so it's easy to fix, right? Oh my God, sorry.
And in the menu option, secure is set to false. So it doesn't matter if you set the TLS config here in your test because you've already configured the client to not use HTTPS at all. And of course it fails,
Mhm.
right? I think you, so the test, I think needs, in the test, I think it needs to, you need to flip that insecure,
Yeah.
um, set it
Mhm.
to false in your, so you need to write a
Right.
new case for TLS with CA,
Mm-hmm.
func test new client TLS, and in there set insecure false.
Right.
And then it should use the CA and the client should try to call over HTTPS.
Mm-hmm.
Right? Because we have a global configuration for all the tests, and we set there we tell the client to use HTTP. That's why I think your test
Mm.
will.
Yeah, actually, now that you're saying, I had the same issue when I was testing locally in the cluster. I had to put insecure false in the object, and it's just the same thing in the code test now. Yeah,
Yep.
makes sense. Cool.
Oh.
Oh, one more
Thank you.
thing. You said about generating the certificate, right? In source controller, we already have some generated certificates. I think we can reuse those. In the internal controller directory, there is a test data file, a directory, I think.
Oh, cool.
Internal controller test data has a search directory,
Internal
which has a make
controller,
file,
test data, certs.
search,
Okay, there's a
and that has a,
CA.
you can just mount it to the menu container and use it, maybe.
Great. And those like these certificates here, they'll have a long
You
valid.
can configure it. I think there is a config file. You can change it to change the validity. And the make file can be used
Oh,
to
cool.
regenerate
Is there
these.
any other tests which I can look at that are using this stuff so I can
Yeah,
There
the
are some, you can do a search.
like
OCI repository has
OCI repository? Cool.
OCI repository has support for custom CAs and MTLS, right? So
Cool.
those
Cool. So
certs are
just take a look
generated
there.
for those tests, so you could actually reuse the same certificates. There is no issue. And
Great.
then when those expire and someone rotates them with the make file, it will also fix the menial one, so you don't have to have more than one set to rotate and take care of.
Cool. Nice. Nice hints. Thank you. And
Okay,
sorry for being late.
no worries. Okay, we are at time. We can go back to release planning. Okay,
Okay. Bye.
bye everyone.
Bye.